Hi, I am Steren Giannini, Senior Product Manager at Google Cloud. Welcome to What's New in Serverless. Today, we are mainly going to talk about two of our serverless products, Google Cloud Functions, which is serverless functions, and Google Cloud Run, which is serverless applications and containers. First, I want to call out that serverless is available in every Google Cloud region. You will find Cloud Run and Cloud Functions in all of the Google Cloud regions. And you can expect us to open up those products in future Google Cloud regions. All right, let us dive into Cloud Functions. So first, we've been hard at work delivering new runtimes for Cloud Functions, new programming languages. The first one is Ruby, then is .NET Core, PHP, and we've also been updating our existing runtimes with Python 3.9 and Node.js 14 and even 16 in preview. Next, we added more customization to the build process. So you might know that when you deploy your function on Cloud Function, the first step that happens is that this function is built before it gets deployed. So you can now customize where that build happens by targeting a private worker pool. This allows you to customize the machine types on which the function will be built, or to ensure that the function is built within your VPC SC perimeter. We've also added the ability to define build environment variables. So these envars are envars available at build time. They, for example, help you configure the build pack behavior. And finally, we delivered min instances to Cloud Functions. So we've been hearing from you that cold start is a problem with function as a service. So what is a cold start? When your function receives no traffic, its number of function instances are scaled to 0. But then when traffic arrives, Cloud Functions will scale from 0 to 1. And the time it takes for the function to start is what we call a cold start. Thanks to min instances, you can simply define a value that Cloud Functions will scale down to, keeping one or more instances warm, so that when the next request comes in, there are already some warm instances to process them. So when not in use, those warm instances are charged for memory, but also for CPU at 10% the price. To use min instances, you can do so via a simple command line flag or a user interface input. All right, now I would like to call out two of the Google Cloud orchestration products that pair very well with Cloud Functions and Cloud Run. The first one is called Event Arc. So Event Arc allows you to asynchronously deliver events from Google services, software as a service, and your own apps to serverless products. Event Arc has added a few new features: the ability to target Cloud Functions, the ability to receive events from cloud storage, and a new standalone user interface that allow you to manage your Event Arc triggers in a central place. Second, I want to call out Workflows, which is Google Cloud product to orchestrate, automate Google Cloud and HTTP-based API services with a workflow that you define. So on the right, you can see a screenshot of the user interface where the workflow is using a comprehensible syntax, but can also be visualized in a very nice graph. So Workflows has added a few new features. First, the ability to use HTTP callbacks, the ability to connect to many Google Cloud APIs. It has increased the memory as well as the number of concurrent executions. And there were many syntax and library enhancements. All right, now let us dive into Cloud Run. So first, I want to call out that we have added committed use discounts to Cloud Run. So committed use discounts allow you to commit to an hourly spend on Cloud Run for a year, and you simply receive a 17% discount on this commitment. Of course, usage above the committed amount is charged at normal rates. This is self-service. From the Cloud Console, you go into billing, you click commitment, and this is where you can purchase a commitment for a year. I should note that committed use discounts apply to all Cloud Run services of your account across all of your projects for a given region. Let's take an example. On the right, we can see an example Cloud Run bill over time. This basically reflects the Cloud Run usage over time. As you can see, because most of the time the bill is above $1, it makes it very economical in that situation to commit to a $1 per hour usage. Because that means that you would only pay 83 cents for every hour. And of course, if usage goes above the commitment, for example, because you used $1.5 of Cloud Run, then you would only pay the discounted on the $1 and 50 cents above the dollar. Now, I want to tell you how we have been improving the Cloud Run developer experience with 3 things following the development journey. First, we have added local development to Cloud Run. Second, we are making it easier to deploy your source code. And third, we improved the observability of your Cloud Run services. Let's take a look. Local development. This allows you to run your Cloud Run services in a local emulator. This emulator is available in the gcloud command line, in the Cloud Code for VS Code, in Cloud Code for IntelliJ, as well as in Cloud Shell Editor, the online IDE of Google Cloud. If we take an example, you can see that you can store your Cloud Run config in a file that would allow you to define how the emulator should be configured. Then, using a simple command, gcloud beta code dev, you start a local development environment that will emulate the characteristics of Cloud Run with the CPU and memory allocation that you've defined, with the environment variables that you've defined, and it will watch your local source code for changes, and when they happen, we'll rebuild them into a container and restart the local server. So quite handy for a fast development loop instead of deploying to the cloud for testing your changes. Then, once you have developed your service, you want to deploy it. We have added support for deploying source code to Cloud Run. This is basically a command, a very simple command in 3 words that will build, push, and deploy your service from local source code. This command is gcloud run deploy. That's right. That's the default for gcloud run deploy. It's to build your local source code using cloud build, push it to artifact registry, and then deploy it to Cloud Run. This command is also leveraging Google Cloud build packs in order to allow you to deploy source code in popular languages without any Docker file. That includes Go, Node.js, Python, Java, and .NET. But of course, if a local Docker file is present, then this command will simply build it with the instructions that are in the Docker file and deploy the arbitrary container image to Cloud Run. Lastly, we added more observability to Cloud Run. First, by delivering a few more metrics, notably the instance count metric, which will show you simply the number of active and idle instances for a given Cloud Run service. Then we've worked with the Cloud Error Reporting team to make sure error reporting was able to capture system errors out of the box. So without any more configuration, that means that if your Cloud Run container instance is out of memory, or if Cloud Run is not able to scale because it is reaching its max instance limit, those errors that are present in your logs will now also be aggregated in Cloud Error Reporting and displayed in a very actionable way in the Cloud Run user interface. And lastly, we have collaborated with the Cloud Trace team to provide out-of-the-box request tracing. That means that you can now analyze the latency of your Cloud Run services using Cloud Trace without any instrumentation needed. All right, now I'm going to tell you how we have made it easier to run more workloads on Cloud Run with 3 changes. First, giving you more control around the CPU allocation of your service. Second, by delivering a new execution environment. And third, by pushing the limits that were historical limits of Cloud Run. Let's take a look. CPU allocation. Let's take an example. Here you can see one container instance of a Cloud Run service. It is starting, then it is started, it receives requests, potentially multiple requests at the same time thanks to concurrency, and then at the end of its life, it gets terminated. Today, the CPU for that container instance would only be allocated when the container instance is starting or when it is receiving at least one request. As a customer, you would also only be charged when the CPU is allocated. And in particular, you are charged for CPU and memory, but also you are charged every time a request arrives. We are introducing the ability to opt out of this CPU throttling by simply saying that you want the CPU to always be allocated to your container instances as long as the instance is alive. So in that case, you would be charged, of course, for the entire lifetime of that container instance. But the CPU will always be available to that container instance. You can enable this via a simple command line flag on an existing or a new service, as well as a simple checkbox in the user interface. So this new option to always have CPU allocated allows you to run background tasks or async processing after you have returned requests. It makes Cloud Run more compatible with monitoring agents like OpenTelemetry. Many programming languages do things asynchronously, like Go routines or async or threads or coroutines. These are now more compatible with Cloud Run. And lastly, you can deploy Spring Boot apps that are expecting to do background things. And as I said, when you opt into this new CPU allocation to always have CPU allocated, you are charged for a different price. There is no request fee, and the CPU and memory is 25% lower. You can couple this always on CPU allocation with min instances, basically allowing you to have a number of instances that are always scheduled and which always have CPU, unlocking some quite interesting use cases. Next, you will find that we've improved the performances of Cloud Run as well as we are adding network file system support. This is thanks to a new execution environment that we call second generation. So basically, when you deploy a container image to Cloud Run, it runs in an execution environment, also known as sandbox. So today, you can opt into the second generation execution environment. Again, using a simple command line flag or user interface button. And this new sandbox has increased network and CPU performance, has better Linux compatibility, and allows you to use network file system like Cloud File Store, for example. And next, I should call out that we are constantly at work to increase the limits of Cloud Run. So first, we have added support for more protocols like WebSockets, HTTP2, and gRPC bidirectional streaming. All of these are generally available now. You can now pick up to 16 gigabytes of memory in preview, up to 4 vCPUs. Each request can run for up to 60 minutes, and each container instance can process up to 1,000 concurrent requests at the same time. This can become very handy if you are using WebSockets and opening many streams on a given instance, for example. Lastly, I want to tell you how we have made Cloud Run even easier to secure by meeting regulatory frameworks, by allowing you to put a secure perimeter around your Cloud Run services, and by helping you secure your Cloud Run services. So Cloud Run is now covered by these regulatory frameworks. We know this is very important for enterprise settings. I should call out FedRAMP Moderate, PCI DSS, SOC 1, 2, and 3. All of these are now covered for Cloud Run. Next, how can you secure or define what is allowed to reach your Cloud Run service? Well, first, we have added support for ingress control. By default, all traffic at the networking layer is allowed to reach your Cloud Run service. But you can now restrict the ingress to only allow internal traffic. So that means traffic coming from your VPC or from Google Cloud, like Cloud PubSub. And you can allow internal traffic plus traffic coming from Google Cloud Load Balancing. Similarly, you can control where the outbound request should go. For example, when you do an outbound request to the internet, you can force it to go through your VPC. And by using ingress and egress settings, you can also enable VPC service control, allowing you to put your Cloud Run services inside a VPC SC perimeter. Thanks to Cloud Run integration with Google Cloud Load Balancing, you can leverage Cloud Armor, which is a web application firewall. And you can use identity-aware proxy to build internal applications that would only be accessible to your employees, for example. And lastly, I want to tell you how we made it easier to secure your Cloud Run services. First, by providing a native integration with Google Cloud Secret Manager. So Secret Manager is a Google Cloud product to store your secrets in a secured place with potentially your own encryption keys. You can now mount those secrets as volumes or as mvars inside your Cloud Run services, allowing you to decouple your code, your container, from its configuration or even its secret. Then we added more security features. Of course, you might know that Cloud Run services run with a certain identity. So that means you can provide a service account that will be used as the identity of the code that runs for a particular service. And this service account can have more or less IAM permissions. Notably, you can remove all permission of a certain Cloud Run service if this one is not expected to call any APIs. We are announcing the general availability of binary authorization for Cloud Run. Binary authorization allow you to define a policy regarding which containers can or cannot be deployed to Cloud Run. And by using an organizational policy, you can enforce binary authorization to be applied to your Cloud Run services in a set of projects. Lastly, we delivered customer-managed encryption keys, allowing you to bring your own encryption keys to encrypt the container images deployed to Cloud Run. And finally, we haven't stopped here. We are proactively producing recommendations to secure your Cloud Run services. The first one that we delivered is to recommend you to use a dedicated service account with a minimal set of permissions for each production Cloud Run services. So to recap, we have added many things to Cloud Run. The first is committed use discount, allowing you to get a discount of up to 17% on the amount you commit. We've improved and we are continuously improving its developer experience with local development, deploy from source code, more metrics. We've increased the workloads that you can deploy to Cloud Run with CPU allocation controls, a second generation execution environment, or just by pushing the limits of Cloud Run. And lastly, we made it easier to secure your Cloud Run services. To learn more about serverless, I recommend you those 3 sessions. Dev 100, which is a great introduction to serverless on GCP, Dev 201, which will deep dive into some very cool features of Cloud Functions, including some that are coming, and Dev 205, which will teach you how to build event-driven applications with Event Arc and Cloud Run. Thanks for joining me today. This was What's New in Serverless. Enjoy the rest of Cloud Next.